Hello and welcome to this episode of the AI Show. Am I a little laggy? I might be. I still haven't fixed my ginormous desktop, so I'm on this like non-superlative device. I'm so spoiled. Hello and welcome to this episode of the AI Show, a weekly show where we show off cool technology than anyone, really. I mean, we've had folks from all over the place. And usually it's very interactive. So I'll start first with the question that I always ask. Where is everybody coming from? That's the first thing I do. The second thing I do is I share my desktop. Hopefully it works. Share. There it is. And usually I write things on the whiteboard here, on the whiteboard to tell everybody what we're doing. But this time, it's not the regular whiteboard, and I don't have my Wacom tablet. It's just not hooked up. I think I figured out what's wrong with it. I think it might be the motherboard, because I noticed a while back that the internet wasn't working on it when I wired up, and that's probably messing it up. Today. Pretty excited about this. We have Wenxin and Jacqueline. And I can't write really well. Wenxin and oh man. Oh. This is so substandard. RAI, responsible AI, but with standard models for text plus vision. That's what we're doing. And then number two, get back to our Rochambeau project. I can show you what it is and download it and get it going again. All right, so where's everybody coming from? Let's take a look at that. Brazil. Welcome, my friend. Got to see the name here. Douglas. Man, old. I need like binoculars. So I have what's called a confidence monitor. It's this thing right here. It has a camera and a glass, and I can see, but it's really hard. All right, Farhad, welcome from Turkey. So glad to have you, bud. I need to go to Turkey. I've heard only delightful things about Turkey. Sweden. Oh, there's a conference in Sweden called DevSum. I have promised that I would go to it, and I need to keep that promise. I promised the organizer in front of his daughters that I would attend, and I am going to keep that promise. Kenya, welcome. Delightful country. From London, that place is fantastic. If I could live anywhere in the world other than where I'm living now, London would be one of them. Yeah, welcome. Love to hear where everyone's coming from. Excited to be here. And like I said, I'm sorry if it is not as crisp as it usually is. I'm using a laptop right now, which makes it kind of not very good. But having said that, it's always a delight to be here. We've lined up some pretty good episodes on how to be responsible. So before we get to that, I thought we'd talk about today is a special day. If you do not know, in the United States, we celebrate a day called Juneteenth. That is today. If you don't know what Juneteenth is, I thought I would just bring it up here, and we can look at what it is together. So I'm going to bring this over here. Juneteenth. It's actually a federal holiday here in the United States. Let's look it up on Wikipedia. So we'll get that going a little bit farther down with the music. Juneteenth, that's today, June 19th. It is a federal holiday in the United States commemorating the emancipation of enslaved African Americans, deriving its name from the combining June and 19th. It is celebrated on the anniversary of the order by Major General Gordon Granger proclaiming freedom for enslaved people in Texas on June 19th, 1865, 2.5 years after the Emancipation Proclamation was issued. Originating in Galveston, Juneteenth has since been observed annually in various parts of the United States, often broadly celebrating African American culture, African Americans making America great since they first stepped foot on this land. The day was first organized as a federal holiday in 2021 when President Joe Biden signed Juneteenth National Independence Day Act into law. So, yeah, that's today. It's a federal holiday, and if I mean, we should have done more, but today we're going to be speaking about responsible AI, which can directly affect minorities, and so pretty proud of that. Early celebrations date back to 1866, at first involving church-centered community gatherings in Texas. They spread across the South and became more commercialized in the 20s and 30s, often centering on a food festival. Like I said, making our country wonderful. Participants in the Great Migration brought these celebrations to the rest of the country. During the civil rights movement in the 1960s, these celebrations were eclipsed by nonviolent determination to achieve civil rights, but grew in popularity in the 1970s. So this is a good celebration. I just want to make sure that we point that out. Happy Juneteenth. If anyone is celebrating, that's great. Okay, let me close my let me close this here. And I think Wenxin, are you ready to say hello to everybody? Give me a thumbs. Yes. Hi, Wenxin. How are you?
Hello, everyone. Nice to meet everyone from the whole world, and happy Juneteenth for those who celebrate it. I think our episode today is very related to like the minority group and how we can bring those like models to be fair and be responsible for different segmentations. So happy to be here.
Yeah, and I'm so glad you're here. Jacqueline's here lurking as well. So if folks have questions for these folks, I thought we recorded these just last week. And I needed to record them because my machine is slow and I need to edit it because there was some choppiness that I had to fix, and it was all my fault. I'm sorry, Wenxin.
Oh,
she was so mad.
Not your fault.
No, she doesn't get mad. She's so nice. Thank you. All right, so what I'm going to do is I'm going to start by adding this video here. So we'll start with you, Wenxin, if that's okay. So let me get this video going. And I thought we would play it, and then are you okay to stay and answer questions?
Yeah, of course.
All righty. Here we go. Part 1 of a two-parter, Responsible AI with text and images. Here we go. You're not going to want to miss the next episode of the AI Show where we talk all about responsible AI support for images and text models, a two-parter. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about responsible AI support for images and text models, a two-parter, one for text, one for images. I've got my friend Wenxin. How you doing, my friend? Tell us who you are and what you do.
Awesome. I'm doing good. Thank you, Seth, for asking. I'm really excited to join this show with you.
Fantastic. So for those that don't know what the Responsible AI Dashboard is, can you give us a little elevator pitch?
Of course. The Responsible AI Dashboard is a single pane of glass that brings different open source tools such as error analysis, model explanation, and fairness metrics all together in Azure Machine Learning. So previously, we have the Responsible AI Dashboard for tabular data, where you can use it for classification or regression models. And now we are expanding the support to models trained on image and text data for different scenarios like image classification, object detection, and text classification scenarios.
That's amazing. And so can you give us a little summary of what that might mean? I have a slide here.
Yeah, so like imagine you are working on an object detection model. You may encounter issues like misalignment of bounding boxes, object overlap, or spurious correlations. Or when you are working on like a text classification model, the model does not focus on right parts of the text to make prediction. In this case, the new dashboard can then help you to identify, measure, and mitigate this issue with our rich visualizations, metadata support, and also enable the entire human-in-the-loop debugging experience.
That's cool. And so this is what all of this new stuff that we're talking about, all of this rich visualizations, metadata support and ingestion, really, this is all part of the new stuff. Is that right?
Of course. And as you can see here, we also adding the new interpretability for vision and text. So we are integrating the open source explanation method as shape vision and shape test, which is model agnostic. And we also developed the DRISE explanation for object detection models in collaboration with Microsoft Research. And the entire user experience is consistent with what we have previously with the tabular data. So it's very consistent and you can debug your workflow by yourself.
That's amazing. So I thought maybe we could spend some time looking at how this works. Do you have a second to do that?
Yeah, of course. Here is how you can generate the REI dashboard for text. So the dashboard is generated from Python SDK or CLI. You can bring your natural language processing model, register it via MLflow, and add this REI text insight component to generate it. Here is an example of the demo we are going to show today. So we use the ESG text classification model as an example. So this example classifies the ESG report into well-classified topics within environmental, social, and governance practices. So this pipeline actually adding this REI text insight component to the Hugging Face model we trained for. So now let's move to the dashboard. When we land into the dashboard, we will see the error analysis component first. This will help us find out where the model makes the most mistakes and what are the blind spots based on the features and metadata we extracted from the model, such as the positive, negative words or sentence lengths. In this case, we see that while the overall error rate is 17%. The error rate can go as high as 33% for those paragraphs that are not too long and have fewer positive words. So for the future investigation into this erroneous cohort, we can save this as a cohort and name it error cohort. So moving on to the second component, which is model overview, we can quickly see the model performance. It performs very well on the environmental topic like climate change or natural capital, which has an accuracy rate about 90%. So for the climate change, it has 97%. While the model performs really bad when the true label is non-ESG, which has a lower 50% of accuracy rate. We also observed that the environmental topics makes up the majority of the example, while the non-ESG data is having a smaller sample size. So I'm also curious to see more pattern around where this misclassification happens. So let's look at the confusion matrix. We can see that the majority of misclassification happens when the model wrongly predicted non-ESG data to fall under an ESG category. We can further diagnose why this happened with the next component. From the data analysis component, there is a table view and a chart view to see the pattern and the distribution of your data. And from the error analysis, we know that the model performs worse when it has fewer positive words and shorter sentence lengths. So we can use this scatter plot. Actually, let me move to the, we can use this scatter plot to identify why. By changing the x-axis, let's use the sentence length as an example here. And we can also change the x-axis to the classification outcome to see the error distribution. And by changing the color value, you will see better visualization here. So from the scatter plot, we can confirm our previous finding that the shorter length has a worse performance because the misclassified examples are in the lower half of the y-axis. This observation will lead us to focusing on this example for the model debugging. Let's go to the feature importance dashboard to see how the model reaches predictions and understand its decision better. Here, it shows the top K important words in classifying text into a topic across the entire dataset. Most of the words seem to relate it to climate change or natural resource like discharges, metal, and it is consistent with the fact that these topics make up the majority of the examples and are better classified. Then in the individual feature importance dashboard, you can also look at a single example to confirm your intuition or drill down into arrows. Here, I want to show a correctly classified example. Let's switch to the old data first. So in this example, the model correctly classified the sentence as pollution and waste. So let's move to the feature importance here. And we can also change the class to pollution and waste, which is the correct label. So you can see here, like the top K important words are indeed related to pollution and waste, such as like waste, recycled, reused, materials. And you can also trace this work back into the context to identify whether it makes sense or not. And from this example, we can see that it seems to be consistent with the prediction from the context. So this type of consistency can add to our trust of the model. And in contrast, let's look at the incorrect example by switching to the erroneous cohort first. So this example wrongly classified the model from non-ESG to fall under the natural capital. So let's examine why. We can change this class to natural capital, which is the model prediction. So we can observe that the short input text has surface, metal, and palm, and this led the model to wrongly predict it to be fall under natural capital based on these words. Well, if we read this sentence, it seems to be out of context. So we did a data investigation into this data subset and find the mitigation method to take actions. So from the data, we know that this is because of the parsing of the PDF, and the model wrongly parsed this table content as a text sample, and it lost all the context about like EPAT. So some mitigation method will be like we can have better parsing of the PDF and include most of the context and ignore some of those footage or the specific table content in the model. And another option is we can also use an image classifier first for this task. So just to sum up, I used a single pane of glass dashboard with variety of capabilities to measure and diagnose my errors and enhance my model accordingly. So to achieve that, the error analysis component helped me identify the cohort with higher error rate. And the model overview and confusion matrix help me understand the direction and type of error. And finally, the data analysis and feature importance component help me diagnose the issue better by better understanding my model decision. So overall, this component work together to help me pick the targeted mitigation and enhancement plan around my model. So that's the end of my demo.
That's cool. I have like 1,000 questions because there's so much cool stuff in here. Let's go back to the beginning on the actual code. And the first question I have, as I'm looking at this, I'm talking about the first tab. So basically, you've trained a text classification model into several categories. Am I getting that right? Is that right?
Yes.
So once you get that model, you're basically putting it into this RAI text insights component thing. Is that right?
Yeah, exactly. So this is a Azure Machine Learning component, and where you can pass into your models, you can also pass into your test data. And once you are adding this text insight component, like all of the different components I just showed will be automatically added to your model and generate this REI dashboard.
I see. So once you run this, then that's when you get the stuff in the second tab.
Exactly. So this is what you are going to see offline. And this is a very, very clean example. Like you just need to bring your model, your data, and bring the REI text insights.
Cool. And then the last thing you have is the actual output of the dashboard. Is that correct?
Exactly. So after you have run this entire pipeline, finish running, you can find this in your model page, and you can go to your model page. You can see here, this is the model page. And there will be a Responsible AI tab where you can access the Responsible AI dashboard you just created.
And there it is. Well, Wenxin, this has been amazing. Thank you so much for spending some time with us. What's in the future for this type of text REI dashboard?
So you can find out more about like how you can generate the text dashboard with the Microsoft Docs. And you can also find out how you can better understand the text dashboard with our documentation as well. And we are also going to have more support scenarios such as question answering. And of course, I know everybody is very enthusiastic about the large language model. And yes, we are working on that. We will have more REI support for the generative models as well. So please stay tuned.
Amazing. Well, thank you so much for spending some time with us, Wenxin.
Thank you, Seth.
Awesome. And thank you so much for watching. We've been talking all about responsible AI support for image and text models. Part 1, we did text models. Stay tuned for part 2, where we talk about image models. Thank you so much for watching, and hopefully we'll see you next time. Take care. All right. That was delightful, Wenxin. That was pretty cool. So hopefully you could tell that my laptop was like, did you notice that, Wenxin? I started to slow down and look all pixely.
No, I know. Like it happens for me as well.
Oh, well, okay. So a couple of things that I wanted to ask that I was like, oh, I should have asked this in hindsight. The first thing I wanted to ask was, are people using this already?
Yeah, so we have already tested with a lot of our external customers. Like one example is with like ERM, which is like a consulting company. They have a very similar ESG use case as I just showed in the demo, and they built a very cool like machine learning based solution, which is called ESG Fusion with the Responsible AI dashboard. And they claim that the REI dashboard can add more like robustness and transparency to the model, so they can better understand how the model making the predictions.
That's really cool. I love the idea of being more responsible with our models, especially knowing what they're doing. Because I don't know if people realize this. Why do you, well, why don't you tell us, why is it so important to be responsible with these models, and what can we do beyond just making models?
Yeah, I think previously a lot of people saying like machine learning, especially for NLP and computer vision, like those models are more like a black box. So you cannot really see how the model is making those predictions. You don't understand like what will be the error distribution. And being responsible means like you can have a better diagnose of your model. For example, whether your model is fair enough, whether it performs similarly for different gender, for different ethnicity group. I think that's very important for like the fairness of AI, the safety of the AI. And I think that's also a lot of people worrying about right now. They want to understand how those new technology is working.
And that's fantastic. And by the way, get your questions in. Wenxin's here for a little bit longer to answer questions. One of the things that I also forgot to ask was, I noticed that it had word level kind of things when it was doing the responsible AI. Did I miss that, or did I get that right? And what is it? How does it doing? Because I know that, for example, I might build an NLP model that projects into like embedded space, but would our AI dashboard still work and look at word level type stuff?
Yeah, so what we just saw in that individual importance dashboard is more like a word level analysis you can do. Like, so if, for example, for each of your text sample, you will be able to see like which word from your original data set contributes more to this model predictions. And we have this like shape text, which generates the feature importance.
I see. So it's Shap text that does the work behind the scenes, but everything
Yeah.
else is open source. Are we using open source things, or is it something proprietary to Microsoft?
So most of the items in the tax dashboard are open source, and we have also open source all of our technology we are using for the tabular dashboard, and we will be open source everything we have built for the tax vision dashboard by end of this month. So I know like Microsoft is always embracing like open sourcing, and we want everyone to have access to these responsible AI tools. So yes, we will be open sourcing everything we have.
How delightful and how responsible to do responsible AI stuff. All right, Jacqueline, are you ready to come on? Let's see if she's ready. Maybe she'll give me a thumbs up. And then also, if you have any questions about this stuff, you'll see Peggy put some links into the chat, so you can go to those things. They're delightful. You ready, Jack? Give me a thumbs up. Okay. Hi, Jackie. How are you?
Hello. Nice to meet you all.
It's good to see you.
I'm good. How are you?
Great. All right. So what I'm going to do first is I'm going to play the video that we had, and then are you okay staying around for some questions? And
For
then
sure. Yeah.
we'll answer some questions as well. Okay, cool. So let me go here because I have to actually add the video real quick, and then we will play it. Here we go. Part 2 of the Responsible AI Dashboard, but now with images. Here we go. You're not going to want to miss the next episode of the AI Show, where we talk all about responsible AI support for image and text models, part 2 of a 2-part series of the Responsible AI Dashboard. Make sure you tune in. Hello and welcome to this episode of the AI Show, where we're talking all about responsible AI support for image and text models. I have my friend Jacqueline here. Why don't you tell us who you are and what you do, my friend?
For sure. Thanks, Seth. Really excited to be here. I've been working on the responsible AI tooling for object detection models, and so excited to be able to share that with you all today.
Fantastic. So if you can give us, people can watch the part 1, but if you can give us a sense of what the RAI dashboard is, and then maybe what it looks like pointed to the image problem. Can you do that?
For sure. So essentially what we want to do here is to really accelerate the responsible development of both text and image models, focusing on image today. And so we'll be diving into how this dashboard will be able to help ML professionals to holistically assess and debug their models for any kind of fairness issues using Azure Machine Learning's responsible AI dashboard.
And that's cool. I've always found, like, how do you do that with images, though? So I'm interested in what that looks like. Can you show us a little bit about how one might go about this?
For sure, for sure. All right, so what you see here is the responsible AI dashboard for image, specifically for the object detection scenario. And so I'll be showing just a quick walkthrough of how you can be identifying fairness issues in your models and data, diagnose why those issues are happening, and inform more targeted mitigations. And so here today, we'll be focusing on an object detection model's predictions on images from the MS COCO dataset, and how we can use the dashboard to debug those predictions. So
Nice.
The responsible AI dashboard for object detection has 3 main features. It has the model overview, data explorer, and model interpretability. And so to start your analysis, the model overview here provides a comprehensive set of performance metrics so that you can evaluate your object detection model across data set or feature cohorts. And so in the data set cohorts pane, you can view these performance metrics across all of your data and how that compares to any dataset cohort you create. For example, here I have a group of images of people with either skis or snowboards. And since I've selected the person class from this dropdown here, the table now shows the average precision and the average recall scores for detecting the person class. And to evaluate your object detection model's confidence, you can also set the IOU threshold value. IOU here refers to intersection of union between the ground truth and prediction bounding boxes. And so this really defines error and affects the calculation of these model performance metrics. And so this can help you better evaluate your object detection model. And at the bottom, we do have metrics visualizations that provides a visual comparison of performance metrics across the dataset cohorts. And so these insights are useful because a common issue in responsible AI is that a model may have high accuracy overall, but perform poorly for certain subgroups of data. And that can result in unintended harms. For example, a face detection model can perform worse for certain ethnic groups than others. And so these failures are hidden if we only look at aggregate performance metrics and not kind of segmented into groups of data to evaluate the model. And another lens to evaluate performance is based on feature-based cohorts. And so for fairness evaluation, this is useful if you want to examine your data based on sensitive features. And the feature cohorts pane, you can automatically create a default of 3 cohorts split according to values of a feature that you specify. Or you can also adjust which features to use to evaluate your model's fairness and determine the number of feature splits that can be used here. And so with more granularity of feature splits, you may be able to more precisely pinpoint those error cohorts. All right, now moving on, we can use the Data Explorer component to further debug and diagnose any discrepancies that you notice in the model overview section. And so this Data Explorer has various views to provide different perspectives of your data. And so first, the Image Explorer here allows us to easily view all of these image instances and predicted and ground truth bounding boxes by segmented by both error and success instances for you to observe any error patterns. And so here I can filter these images shown by index and classification outcome. So for example, maybe based on previous observations of model performance across feature cohorts, I may want to specifically investigate certain images that are based on certain feature values. I can also stack multiple features, multiple filters, and kind of create a new cohort from there. And then next, we have the table view. And so this pane shows different metadata features along with the dataset index, ground truth, predicted class labels for each of the image instances. And so this is also where you can create a new dataset cohort to analyze in a more granular manner. See, I'm kind of manually selecting these images here, and I could save it into a new cohort for more evaluation. And then lastly, we also have the class view pane, which breaks down your model's predictions by class labels. And I just also want to highlight here our last kind of cornerstone feature, which is being able to access visual explanations for model behavior leading to object detection. And so this is really helpful to debug what contributes to misdetections and any biases that may occur. And this is really unique to the object detection scenario. So going into this feature here, if I click on this instance, I can see that the model's prediction is aligned with ground truth. It's a successful instance. The person and the ski was correctly detected. And this visual here is a saliency map that highlights parts of an image that contribute most to the model's detection. And so this is generated by visual explanation methods, which is MSR's open source package that implements DRISE. DRISE is a model agnostic method to visually explain your object detection models that you can learn more later in our blog and technical documents. In this feature, in this visual, I can see that really highly salient pixels, as indicated by these really intense warm colors, are focused on the correctly detected person. And so there's no, as you can see, there's no saliency pixels towards most of the skis. And this shows that the objects around the person don't contribute to the prediction as significantly as the person itself, which is what we desire from our model. And so this is confirmed behavior, but when we look at the skis and how the model detects the skis, notice that there are saliency pixels on the skis here, and so on the person's legs. And so this may imply that the co-occurrence of the person and the skis is leading to bias in the prediction of the skis. And so imagine if there was, a pair of skis on a wall, would the skis be successfully detected without a person? And so this would be, maybe an area of investigation I would want to go in, where maybe I'd want to consider adding more images of just skis without the person to avoid the model making spurious correlations between the skis and the person object, even if this leads to a correct detection. And so you can kind of repeat this process even with misdetections. And yeah, that's basically what we have with the object detection dashboard.
Wow, this is really cool. So I'm going to ask a bunch of questions if that's okay.
For sure.
So is this, how is this, does this work with any computer vision models, or do you have to train the models in a specific way? Does it come from automated machine learning models, or how do you get those models? And then is there, in the last video, we saw a process where you had to actually explicitly tell it to make this dashboard. Is that the same process? So the first question is, what kind of models? And the second is, how do we make this dashboard?
For sure. So for models, this dashboard covers both AutoML and non-AutoML models. For non-AutoML, we cover PyTorch models, so that includes Hugging Face, as well as others. And in terms of setting it up, I think that was your second question.
Right.
This goes to the same process as setting up a text dashboard. And so you can look into, or maybe our documentation for certain kind of other details that differentiate the two.
It's basically a call to a component run kind of thing.
Yes. Yes.
Okay.
Yes.
So then the third, I'm already on number 3. There was a lot of this notion of mean pixel value. Remember, you were able to separate the cohorts in the mean pixel value greater than. Is the mean pixel value, and if I sound really dumb, that's it right there. Let me know if it's the wrong thing. Does that mean the average value of the pixel?
I believe so.
Okay.
Yeah.
And I think that's cool. If that's the case, that's actually really cool, because it lets you look at images based on saturation to see if there's bias with darker images versus lighter images, which is, I mean, I'm not trying to say anything, but that is actually really cool. So the last thing I want to ask you, and this is probably the fun bits, is where can people go to find out more about this stuff? I know you gave me some links. Here's the first one. What will people find here in the RAI Vision Insights?
For sure. So this is our link to our technical documentation. And so if you're looking into detailed information of how to set up this responsible AI dashboard and what all these components mean, any limitations or guidance on like your data set and your models, this is where you'll find all of that information.
Fantastic. And it looks like this helps you understand the dashboard as well. This one, right?
Yep. This goes into the dashboard components and what each of them mean, while the first one was more on setup.
Amazing. And like I said, the RAI dashboards I still need to dive in and understand, because there's so much information there that it's even overwhelming for me. So make sure you take a look at this. And then finally, before we go, there's a cool blog that will talk about both the text and the image RAI stuff. Is that right? Is that what this blog is?
So this blog primarily talks about the image, particularly the object detection scenario that I just walked into. Yeah.
Fantastic. Well, awesome. Well, thank you so much for spending some time with us, my friend.
For sure. We're happy to be here and to share. Thank you for having me.
Amazing. All right. Well, you've been learning all about the responsible AI support for images and text models, part 2, where we talked about images. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? Good job, Jacqueline. That was awesome. Oh, can you hear me?
Yes, I think I was just muted there. So making sure I was unmuted. But yeah, that was great to get into that.
So there were actually some good questions here, and I want to put them up. So I'm going to move my window over here. So if you see me looking to the side, it's because I'm looking at the first question was, and maybe I can help answer. Are CNN architectures still the best for image classification detection, or have transformers replaced them? I haven't heard of transformers doing image stuff, but maybe I'm old. Do you have any sense for that, Jacqueline?
I want to say it's by case and experimentation basis. But but I'm sure there's a lot of research and a lot of folks from Microsoft Research that can chime in on this topic. Any thoughts for you, Seth?
That was such an awesome answer. That's how you know she's seasoned. This is how you know you have a seasoned consultant. They say, well, it depends. Awesome question. Yeah. Another question, and I don't think this actually relates to this topic, but maybe you know, how do we generate our custom image with high definition? So custom image generation, they're probably thinking like stable diffusion or generative models. This RAI stuff really doesn't really contemplate this kind of thing. Is that correct?
No, it doesn't really go into generative images, but a use case for this would be, say, if you had like a content moderation tool for the custom images that you're generating with generative AI, then you could be able to use this to evaluate the content moderation tool itself to see, is it really detecting the harms in your generated images as well as it should be. So you can also be using Azure Content Safety for that, for those who are interested.
Yeah. That is amazing. Yeah. So when you're looking at generative AI, particularly with text, if you're using, Wenxin brought this up, if you're using a generative AI specifically with text, Azure Content Safety is really good at making sure that you can moderate across 5 axes, if I remember right. I might show you that later if we have time. All right, and let's see what other questions. Yeah, there was a ton of people here today. Make sure you check out the links. Microsoft Developer has been very nice. There's the links for the RAI dashboard. And then here's the one for images as well. Well, Jacqueline, any final things that you want to talk? Oh, here's another one. Is the vision for that all MSFT, Microsoft RAI tools, traditional as well as LMs, will be part of the AML RAI dashboard eventually? Oh, that's a really good question. Are all of the like everything we do with RAI, is it going to form part of a single dashboard, or is a dashboard more of a modular thing? Because I noticed there's different components to it. Thoughts on that?
Right now, I think it is definitely modular, but still in the works in terms of how that will all fit in. And probably Wenxin can also chime in maybe in the chat for kind of future plans on that. But yeah, tune in for more.
Awesome. Well, thank you so much, Jacqueline, for being with us.
For sure. Happy to be here.
All right. And Wenxin saying that eventually all of these things will be converging. But I think that's a really intelligent part of the design, that it's all modular and it's all components and you can add part of the thing. And so I think it's great. Well, thanks so much, Jacqueline. We'll see you next time. All right. Here we are. We have about 15 minutes left in the show. And I was going to do Rochambeau, but I thought that 15 minutes will probably just let me download it. And so I thought, let's go look at something here that I want to show you. And let's be helpful on the community today. And I want you to be helpful on the community today. So let me share my screen here. So I'm looking down here. Let's share the entire screen. Doop-boop. So dumb. I'm like making sound effects because yep. Okay. So what you're looking at here is this is the GitHub community. And I work for some really good folks here on this stuff. So one of the things that I want you to look at, and thanks Wenxin and thanks Jacqueline for coming by. They're fantastic folks. Wonderful. Speaking of community, the thing I wanted to show you was this machine learning and ML ops. This is something that I've taken on, me and Cassie together. If you go to machine learning and ML ops, there's questions, and we launched this new machine learning category. Zoom it. Machine learning projects and models are pretty awesome. Turns out a lot of GitHub features, turns out that a lot of folks happen to put their ML code on GitHub and even use some of the amazing features. So this is a trial that we're having, from April 1st to September 30th. So let us know. Now, the thing about this is I want this to succeed. So it's like a trial thing. They're letting me do. They're letting me do it. And so people are asking questions already. Oh, what? Wow, what's going on here? So let's go in and answer some questions together. Most implementation, okay, faster RCN implementation, 32-bit floating point, high precision images. Most implementations are 8-bit images. I wonder if anyone has worked with this model using 32-bit floating point images. What's the use case? Have you tried it? Geospatial application. I don't know what's going on here. Interesting. What have you tried so far? My sense is that I mean, what do y'all think? Here's what I'm gonna say. My sense is that with more quote numbers to crunch, it will likely be slower depending on the model architecture. Have a repo or other things we can look at to have better suggestions? All right, we reply there. Boom. Okay, let's go back to the discussions. Machine learning. We answered that one. GitHub dataset. Here's a good one. Where can I find an up-to-date GitHub dataset? Crawling GitHub don't look good. Doesn't look like a good way for it. But this is about 2021. GitHub has an official free up-to-date version. Could be the brute data for LLMs. Check out this. Oh. Oh, here it is. GH archive. Finding an up-to-date GitHub dataset can be a challenge, especially considering the constantly evolving nature of programming. Currently, might not be the ideal approach due to various reasons. The REST API datasets. Wow, this is great. So I'll just leave this one alone. Looks like the community's got that one. What else we got going on here? Installing some libraries. That's simple. Collab, copy labs at Unity file. Oh, looks like this one. We're going to mark this as an answer. Good job. Well done. Nice. Beautiful. So yeah, I'm trying to make this the community thing. Is this a machine learning thing? TensorFlow. Here we go. Oh, nice. We'll just mark this as the answer. Boom. Wow. Oh, see? Yeah, they figured it out. I just looked at a wall of text and I'm like, can you tell me more? I don't know. I have a hard time when people are like, I did this. This is the error message. What do I do? By the way, some folks said hello, and I want to say hi to you all. Looks like we had from Dublin, howdy doodle. We did show the links. Someone asked for some responsible AI dashboard links, and we did that. Евгений, привет, как дела? Все хорошо сегодня? Hi from Lima, Jamie. Jaime, if it's from Peru. Hello from Dublin. Howdy doodle. It's good to see you. Nigeria Delta State. Welcome. We did that question. Hello, Adnan. It's good to have you here, my friend. Thanks for coming. From Pakistan, thank you for coming. Delightful. Hi. Love from Nigeria. And then obviously we have Genescu number 7. Hello, Dr. Ibrahim from Gaza and Palestine. Hello, my friend. Welcome. Cool. All right. So let's go back. We answered that one. Let's go learn AI code. Let's see what we got here. I want to build an AI. How do I make AI for control on? I want to build in AI. How do I that and how to make AI fully controlled on the app? How do I do that and how build in cybersecurity with the app by fully Flutter code language? What is the code to start and does it recommend the app fully controlled by AI or not? Please answer my question. Cool. Wow, looks like they answered in Chinese, which is not helpful. Or maybe it is. This is, wow, man. People are so freaking helpful. I love this. Wow. Well done. This is cool. Now, if you're reading this, you're like, wow, they don't speak. Their writing is bad. They probably, it's not their first language. So props to writing this in English. I mean, imagine if I had to go in and write something in Chinese. I think this is Chinese. Yeah, it's Chinese. If I had to write something in Chinese, I would sound like this, but in their language. So, I mean, kudos. That was awesome. They probably could have written it in their language, and we could have translated it too. So, okay, so we got that one. Learn AI. Okay? Here's another one. Using Google Matcha base from Hugging Face for combining several charts in one. Currently, okay. I am currently thinking of building a prototype for my Udemy course that allows me to combine several charts into a single chart and to compare. I have 3 charts, each with GDP per capita over time. I want to overlay charts into one and ask which one grew faster. Model card for Matcha base model. Matcha defines 2 times per chart. Sorry, you can't see this. Let me make it bigger. There we go. What does this do? Visual language data such as plots, charts, and variety. However, state-of-the-art vision language models do not perform well on these data. Propose Matcha, math reasoning, chart de-rendering featuring to enhance visual model. Jointly modeling plot construction, numerical reasoning. What the heck? I don't think I even understand what this does. Is the goal to take images of charts to extract information and then recombine them? Sorry, I have not answered that one in a while. Okay. Oh, here's another one. Artificial intelligence. I am writing a project on a CNN-based handwritten number. I need help. I need the source code. Let's see what we got here. Open the file. What do we got here? Wow, this feels old. When was this written? (2021). On CNN, SVM's proposed. Is this like a? By the way, let me zoom in because it's probably hard to see. Do. There we go. There we go. Why? I don't understand why you would do this. What? I thought CNN just did this. All right. So let's go back and see. Let's just do this. MNIST PyTorch. Here's the example. Image classification using components. Let me go back here. Okay. Hi, Anya Loveth. Have you tried looking at some of these samples? There's a couple of image recognition examples there that might be helpful. Ah! It's time for our walk-off music. There we go. Comment. Nice. Nice. How do I know a labeling file format requiring where? I'll mark this as the answer. Thank you, Mohammed Sayed Alal. Okay. Oh, looks like this person. I'm going to mark this as the answer. This looks great. Can I mark multiple answers? I guess I can't. That's okay. I think it's great. Squeeze and excitation blocks for image classification. We'd have to go down. Man. Cool. Yeah. Generally, when I have errors like this, it's always like a dimension issue. It's like something's wrong with the dimensions or something. So I'll just leave that one. Looking for an open source machine learning project. Nice. How to train model on partial. Jeez. We might have to do this. Let's see, stable diffusion. Stable Diffusion GitHub. Wow. We should try downloading this one day and just trying to. Oh, but does it not have? Is it just like, hey, try it here, but you can't download the model? Well, looks like we're out of time for this week. 9:32. I'm already over by a little bit. Thank you, friends, for being here this week on the AI Show. Happy Juneteenth to those that are celebrating. If you're not celebrating, you should celebrate. We have another two-parter coming up next week. Azure Video Indexer with ChatGPT and Azure Cognitive Services weather and climate tracking is what we're doing. I know, Janice, we used to do 2 hours, but we used to do 2 hours every other week, but now it's an hour every week. Next time on the AI Show, like I said before, we have a two-parter. Climate and weather event monitoring with Cognitive Services. Alicia, we went to school together, actually. And then Azure Video Indexer with ChatGPT integration with Edge expansion with Imbal. So make sure you tune into those ones. Thank you so much for spending some time with us here on the AI Show live every week at 8:30 in the morning to 9:30 Pacific. We are glad that you're here. We answer questions. We are helpful. Thank you so much for watching, and hopefully we'll see you next time. Take care.